name is Harold York. I'm a research scientist in Pasadena, California, and I will be talking about the frequency of orbital motion of electrons. Niels Bohr, a physicist who later became a Nobel Prize winner in 1922, had a model for hydrogen, which looked like a planetary system. We have the nucleus, which is one proton, and then an electron rotating around it in orbital motion. Now, the velocity of the electron around the nucleus is given by the formula v is equal to 2 pi r, that's the radius between the electron and proton, times the frequency of orbital motion. And so we can solve this equation by saying that the frequency of orbital motion squared is equal to the electrostatic charge of an electron, E squared, divided by 2 pi squared, divided by mass, and divided by the radius to the third power. Now, in order to get the orbital frequency, we would need to determine the radius. Niels Bohr made the assumption that the angular momentum of the electron, which is mass times velocity times radius, is equal to an integer n times something called the Planck constant divided by 2 pi. So it's a product of n and h bar, where n is equal to 1, 2, 3, and so on. And using this assumption and substituting it into the top equation, we have the relation that the radius of an orbit at for n equals 1, 2, 3, 4 is equal to n h bar squared divided by m e squared. And for n equals 1, that radius is equal to 5.3 times 10 to the minus 9 centimeters. And this is called the Bohr radius of hydrogen. We can now solve the equation, and the energy, for instance, of the n orbital is equal to, substituting in, minus 13.6 electron volts divided by n squared. Now we can calculate the frequency of orbital motion, at least for the n equals 1, and that frequency, substituting in for r to the third power, this number, the Bohr radius, we get the frequency is 6.56 times 10 to the 15 hertz. So I want to stress again, electrons are not tiny little points moving around in orbits. There are clouds, and but if we use the Bohr model, we can calculate the orbital frequency of an electron in hydrogen. Thank you.